to measure the performance of any classifier or classification method. What are those? Okay, we'll learn here. So okay, before I start that one, so we have different classification method. You might have seen in regression method, you have seen how we were measuring the performance of regression. We were using the error calculations, error matrix we were using. We were calculating the absolute error, okay, absolute mean squared error and absolute root mean square error. Okay, so we were calculating this type of errors, and based on that we were evaluating the method is good or not. In the same way, the classifier, we have different classifier. Recently we have learned the support vector machine, and we have the logistic regression. We have the Bayesian classification methods. Okay, Bayesian classification method, sorry, new Bayes classification method, and we have learned the LDA also, that is the linear discriminant analysis, and also we have covered the neural network. In the topic of perceptron we have covered, that is the artificial neural network. So how many method we have covered? SVM, okay, and here second logistic regression, third one is the new Bayes, and fourth one is the linear discriminant analysis, and fifth one is the artificial neural network. Okay, so these many methods we have learned, we have applied on different data sets, and we have seen the results. Okay, so what happened, for suppose you have some particular problem, you have a data set D, which is the patient data for which tells the which contains the cancerous, okay, the cancer data set we have for patients. So in that, some patients are, they are suffering from the cancers, and some of them they are not suffering from the cancers. So I want to develop a model, okay, so which will tell, it will tell whether the particular person is suffering from the cancer or not. Okay, so for that we need to build a model. So I can use support vector machine, somebody can use the linear regression or logistic regressions, okay, and new Bayes classification, LDA and ANN. Different methods are available. Now the question comes, which one is good, which one is good predictor for this, or the good classifier will be which will be the best classifier proved for this work. So how I will judge this one? So for that we use this matrix. For your examinations also, you conducted to evaluate yourself by giving some questions, and you give the answer, the evaluation is done, then based on that you get the results. So for particular same problem, for detection of the cancer in the patients, okay, which method will be good, how I will choose, the answer will be the evaluation methods. Okay, so we will perform the evaluation using the different metrics, and then we'll come to know which method is better. So here you can see, here the first thing is the confusion matrix. So confusion matrix is it is a tabular form. The data, the results are arranged, and based on that we perform some of the calculations. Okay, so we first create the confusion matrix, and it is nothing but a tabular representation of the results obtained after the execution of the method. Suppose I am using the SVM, so for SVM I will get some results, okay, based on that at the time of time of training, I add these values here. So you can see here we have the actual class and we have the predicted class. Actual class means the original result. What is the original class? And we have executed the classifier and then we obtain some result. So that will be the predicted class. Okay, the answer that you obtained. So definitely if you are performing some experiment, your answer may not be completely 100% true. So that variation we are recording here against the actual. So here what we have to mention here. So first one here, C, if I denote C as a cancer person, okay, the person suffering from the cancer, and it is a negation sign, means the person is not suffering from the cancer. So two classes there, one is the cancer yes and no, you can see here. So this is the negation sign. So now we can keep here the records and numerical value like this. First one is the true positive. TP means true positive. So how many true positive? True positive means I have tested for a person who was suffering from the cancer and my result also came same. So I will make it true positive. Okay. Next one is the false negative. Okay. So this is the false negative. And false negative means the person is suffering from the cancer, but my classifier is telling that the person is not suffering from the cancer. So it is very dangerous thing. So it is a false negative. True negatives means the person is not suffering from any cancer disease, but the yes, and the answer is also coming the not negative, means suppose some person went for the testing purpose, he is not suffering from the cancer but he was having some doubt, okay, and he went and he came negative, okay, so that is the true negative. Okay, here false positive. Next one is the false positive. So what is the meaning of false positive? False positive means the person is not having the cancer, but my classifier, my classification method, it is telling that, oh, you are suffering from the cancer. Okay, although he is not suffering from any cancer, but my classifier is telling you are suffering from the positive. So what will happen? The treatment will start for unnecessary. So these are the representation that we have in the tabular format, okay, that we call the confusion matrix, and all other calculations will be based on this confusion matrix only. Okay, so understood what is the meaning of true positive? Hello.
Yes, sir.
True positive means the person is suffering from the disease or cancer and my classifier is telling yes, he is suffering from, means both the answer are matching. Here in the diagonal you can see here in the diagonal both are for the correct answers. In this diagonal means he was suffering from the cancer and my classifier told he is yes, he is cancerous, suffering from cancer. Here true negative means yes, the person is not suffering from the cancer and my classifier is also saying the same, so it is the true negative. Here you have in this diagonal you have the wrong answers, that is FP and FN. Okay, understood this one? Okay, now come to the next one. The example you can see here. What is that? Bayes very familiar example we are taking here. Bayes computer yes, and this is Bayes computer no. Okay, actual versus the predicted. Bayes computer yes and Bayes computer no. So I performed the this prediction using any method. Okay, suppose this time I am using the logistic regression. Okay, I am using the logistic regression, and my logistic regression method what is telling he given the data. How many came true negative, true positive? 6954 came true positive. Means the person I expected he will buy, in the original class he was buying the computer, and also when I performed by my classification methods the answer came the true positive. So 6954, and here you can see here the 2588 they came the true negative. Okay, I expected suppose particular person will not purchase, but actually he also not purchase the computer. So this is the correct, this diagonal, true positive and true negative. This is the false negative and this is the false positive. Some, okay, this is the false positive. So how many false positive? 4, 1, 12. And how many false negative? 46. So if we add all these numbers, now you will get this number. If you will add these numbers, now you will get this number. If you will add in this, now the below, then you will get this number 26, 46 and 2588. You will get the 2634. And here 7366, you will get this one. Okay, and if you add this one and this one also, then you are getting how many? 10,000. So actually out of 10,000 records the result we obtained like this one. Okay, so given m classes and entry, okay, CMI ij in a confusion matrix indicates number of tuples in a class I that were labeled by the classifier as class I may have extra rows columns to provide the totals. These are the extra totals. Okay, but the main thing is true positive, true negative. This is the false negative, and here this is the false positive. So this thing, this confusion matrix you have to draw in your notebook so that you can recall later on that we have prepared this type of tables, so it will recall later on. Understand up to now? Any confusion? Any confusion in this confusion matrix? What is a confusion matrix? Hello?
It is one of the matrices.
Yeah, it is a matrix. What is the matrix? But what it contains? It contains that it contains the result, okay, in a tabular format classified into the classes. You can see. Okay, now come to the next one. You can look here. So you can, in short, if you want, you can draw this. This is also the same, the summarized way. So it is nothing but a summary of the result obtained by your classifier. So we have to calculate the accuracy, error, sensitivity, and specificity. These are the different metrics that we compute for evaluation purpose. Okay, so here actual versus the predict. Cancer is there, cancer not there, cancer is there, cancer not. So your positive class, negative class, positive class, and negative class. You may name anything. Okay, here it will be the all positives, here all the negatives, and it will be all positive and negative will be added here. Okay, so what is the meaning of this P? P means all TP plus all FN, both will be added, so it will, you will get the P, and here N means FP and plus TN. Okay, you can look here. Here also, if we add in this direction, so you will get P dash N dash. If you will add all, then you will get the, what is all means? T true positive. All means what? All means what? True positive plus for true positive, false negative plus false positive, and true negative. Okay, so this is all. This is all. Now coming to here, classifier accuracy. How to calculate the classifier accuracy? So classifier accuracy is very easy to calculate. You can look here how we can calculate. See here, how many true answers we got. How many true answers we got based on this one. The true answers are in this diagonal. True answers are in this diagonal. So what is that? True positive and plus true negative and divided by all. Means you will put here everything. True positive plus false negative plus false positive and plus true negative. So if you will calculate this numerical value, then you will get the answer of accuracy. So my classifier like accurate in this way. Understood? Suppose if it came 50 and here total is 100. So what is my accuracy of the classifier? What will be the accuracy of my
0.5,
classifier? 0.5 means
50%.
50%. Okay, 50% accuracy is there. Means if I am using my classifier, the answer going to be true answers may be the 50% chances. Okay. Next one is the error rate. You can calculate. Just you have to subtract the accuracy from the one. Okay, so you will get the error rate, and you can also calculate the error rate like this one. What is the error? This diagonal is representing the principal diagonal. You are seeing you are watching from top left to right bottom. So that is the this one is the all the answers are correct, but if we concentrate on this one, okay, this diagonal like Fn and Fp, so these are the wrong classification done by the number of wrong classification done by the classifier. So for that what we can do, we can calculate the error rate. Error rate means Fp plus Fn. Okay, you will be having some count of Fp and Fn, then divided by all means you have to put this value. Okay, so you will get the error rates. Okay, these very important discussions we are having over the evaluation methods. Okay, so you keep in mind. Next thing is class imbalance problem. This is not any metric, but this is a point we the issue that generally happens in the generally we see in the data sets. So what is the problem of class imbalance? Okay, we'll see. So class imbalance means if you are having any data sets, so in that suppose I am having x1 x2, okay, and then you will be having y, means here in the tabular format. So this is the class level and these are the features. So what happens, you will add the different features, you will get the labels. Suppose yes and no. Okay, yes and no. In this way you can come. So if in your data sets number of S is more and number of no is very less, or number of S is very less and no is very high, so what will be happening? So there will be imbalancing. Imbalancing means here suppose you are having the balance weighing the things, so you are getting number of no's very high, okay, and number of S is very low. So what will be having? The class imbalance issue will come. Okay, So if the class imbalance problem is there in the data set, that is the problem for your, because it will learn whose numbers are there more. Suppose no class instances records are more, so it will work more for that instances, so it will learn more for the no class, but for S class it may learn very less. So this type of problem arises in the classification method, that we call the class imbalance problem. Okay, so one class may be rare. Rare means very few examples are there for them. Easy the fraud. Suppose in the bank na various transactions is happening every day, but fraud will be very less na. Okay, the true transactions means the legitimate transactions will be very high, but the frauds generally happens rarely. Okay, so if we train for this detection of fraud and the true transactions, so if we collect the training data sets, the imbalancing will be very high. Okay, so suppose, and also for like some diseases like HIV positive. So HIV positive, if we see the records, in the records HIV positive very less, but the number of not negative HIV will be more. So if you train in such data sets, the classifier performance affected. Okay, so significant majority of the negative class and minority class of the positive. So next term is the sensitivity. Okay, this is the problem, not a matrix. Okay, so here sensitivity, how we calculate the sensitivity. So the true positive recognition rate we call the sensitivity. This can be calculated by the TP by P. Okay, TP by P. P means all P's. This one TP plus Fn. It will be TP plus Fn. Okay. So this can be, and specificity we can calculate, that is the true negative recognition. Okay, true negative recognition means all Tn. What is the Tn? This one Tn means true negative, and divided by n. N means this one Fp plus Tn. This will be the Fp. N means Fp plus Tn. Understood? Just you have to note down this one, you will see, and whenever you are getting the results you can very easily calculate. Just calculation based on this formula you have to do. Okay, now next method is the precision. Precision is also very important evaluation metric here in the classification method. And what it does, you can look here. The precision estimates what percentage of tuples, means records, that the classifier labeled as positive. So precision, how to calculate the precision? TP divided by TP plus FP. Okay, TP divided by TP plus FP. You can see in this one, this TP and FP. In this way we have to add. So TP plus FP. TP true positive divided by true positive plus false positive. So it will tell what percentage of tuples that are that the classifier labeled as positive are correctly positive. And next method is the recall. So precision and recall are very important. Accuracy, precision and recall, and F measure. These are the frequently used these metrics for classification evaluations. Okay. So it tells, recall tells what percentage of positive tuples did the classifier labeled as the positive. So recall is calculated how? TP divided by TP plus Fn. TP means true positive and plus Fn. You can look here, 2 TP and plus. Okay, so like this we can calculate the recall. And what is the perfect score for this? This is the one. What is the meaning of recall? You can understand. Suppose I have given to you, remember, suppose sometimes I take the attendance na, so you may recall the people. So how many? 47 students are there in your class. Okay, I have given the list. I told you you learn all the names with roll numbers. So what you did, you learned everything, and later on what I did, I asked you tell all the numbers, names with roll numbers. So what you were able to do, you have recalled all 47, but when I asked you some roll numbers, okay, you start speaking the roll number and name for all 47, so you could not recall all the person's name, so you could recall only the suppose 70% or 70% or 80%. Okay, so in this way we can calculate the recall. So here also it is done. Recall means TP upon TP plus FM. Okay. Inverse relationship between the precision and recall. Okay. We use this method and we call the F major or F score. Both the names are, sometimes we write the F1. So sometimes we call the F major or F score. So it is nothing but the harmonic mean of the precision and recall. So both precision and recall is combined in one formula, that is the F. F is equal to 2 multiplied by precision multiplied by recall divided by precision plus recall. So this, in this way we calculate the F measure. Why we do this F measure? Okay, maybe your data may be imbalanced. In case of imbalancing in the problem in the data sets, one method is not sufficient, like precision and recall. So what we do for that, we combine these two methods, precision and recall, and we come up with F measure. So F measure, if the data is also imbalanced, then it can consider both the evaluation together in the single formula. That's why we use the F measure. Okay, so you can see here example 90%, and you can see here the results. If I say what is the accuracy, okay, now it's your turn to calculate this one. What is the accuracy of this classifier method? Suppose any classification method we have used, suppose SVM, and SVM has given number of true negative, number of true positive, this one, and number of true negative, this one, number of false negative here, and number of false positive here. Now it's your turn to find the accuracy. So how we can calculate the accuracy? What is the formula for accuracy now? Hello, what is the formula for accuracy?
TP plus TN by R, sir.
Okay, TP plus
TN, sir.
TP plus TN, very good, TN, and divided by
R, sir.
all. So all means you have to all four, TP plus TN plus FN plus FP. So what will be the answer here? How you will calculate? What is the TP? 90 plus what is TN? That is the 9560 divided by how much? All 90, sorry, yes, 90 plus what is that? You are also calculate by yourself immediately, everyone. 9564 plus 210 and plus what is that? 140. So you will come up with how much? 300 divided by how much it will come? 10,000. So how much answer you will get? Hello. What is the accuracy now? Calculate this one. You did some wrong calculations. What is this one number? Number is
9,650, sir.
so you have to add that one. Wrongly I wrote. 1 minute. Here you have to write the answer. See, this one 9. This answer will come how much if you add 90 plus this one? How much it will come?
9,650, sir.
9,650. Okay. Divided by 10,000. So how much you will get?
0.965, sir.
Accuracy will come here na 96.4. 96.4. So for other calculations also you can do. You know the formula I told. These formula are there. You can similarly calculate the sensitivity, specificity, accuracy already, then recall and the precision. And one more thing is not here, that is the F measure. So how we'll calculate the F measure? What is the formula for F measure? What is the formula for F measure?
Harmonic mean of precision and recall, sir.
Okay, so what is the formula? How we'll write? Harmonic mean, how we can write?
2
So
into
yeah, 2 into precision into recall
divided by
Precision
recall
plus
plus
recall.
precision plus recall or recall plus precision. Okay.
Both are
So
same.
yes. So how much you will get? 2 multiplied by precision. How much value is there for precision? For precision, how much? Precision is 39. Very low value is there. 13. Okay. Divided, multiplied by again. What is the recall? Recall
30,
is
sir.
30. 30 means, suppose I have given the names to remember. All 100 names I have given to remember. You remembered, you taken on time. When I ask you speak all the 100 numbers, so you could only 30 numbers you could tell. Okay, and divided by, you have to add this one, so it will come 39 and plus it come 69. 39 plus 13
69 13
plus
point
30. So you will get, what is the answer? You can compute and tell me. So in this way you can make the evaluation of any classifier. Okay. So what we can do later on? So how we can choose which method is good? So based on the comparison, we can compare all the results, and after comparison, which is having the good results, we will prefer for that one. Okay, understood?
Yes, sir.
Okay, so